Okay, today we're going to talk about adding and subtracting polynomials. This is Unit 2.1 in IM2. A monomial is a number, a variable, or a product of numbers and variables with whole number exponents. A monomial may be a constant, or it may be a single variable. So why aren't these monomials? Well, this is not a whole number exponent. This is a sum or difference. It is not a product. And this one, the exponent is in the bottom, in the denominator, and so if you simplified it, it wouldn't have a whole number exponent. The degree of a monomial is the sum of the exponents of the variables. A constant has a degree 0. So numbers by themselves have a degree of 0. So go to Journal, page 36, and see if you can figure out the degree of each of these. Okay, so if you're looking at this one, since the 6 has a degree of 0 and this has a degree of 1, the degree is 1. The W is just a 1. A number by itself is 0. On number 4, you have a to the 1, b to the 1, c to the 1, and you have to add them because it's a monomial. Only monomials do this. Over here, number 5, we have 2 plus 1 is 3. Number 6, we have 2 plus 3 plus 1 is 6. Number 7 is 1 plus 3 is 4. And 8 is made up of constants, and therefore it is 0. A polynomial is a monomial or a sum or difference of monomials. So like we saw in that problem that said, why is this not a monomial? If it has a plus or a minus, it is a polynomial. The degree of a polynomial is the degree of the term with the greatest degree. In other words, you only look for the highest degree. You do not add them. The terms of an expression are the parts being added or subtracted. This is a basic definition that you learned long ago, but it has more significance when we're talking about polynomials. The terms of a polynomial may be written in any order. However, polynomials that contain only one variable, meaning one letter, are usually written in standard form. The standard form of a polynomial that contains one variable is written with the terms in order from the greatest degree, the highest degree, to the least degree. And constants are always at the end because their degree is 0. When written in standard form, the coefficient of the first term is called the leading coefficient. So in this problem, the leading coefficient is 2. So if you were going to rewrite this one in standard form, what would be the order and what would be the leading coefficient? The standard form is written this way. Notice that the 5 is first, the exponent 2, and this is my leading coefficient. Okay, polynomials have special names based on their degree and the number of terms they have. So if you look at the degree one over here, okay, we have constants, which would just be a number. A linear, which has a degree of 1, think of slope-intercept form. We're going to be learning all about quadratics coming out, but that would have any kind of a combination where the highest exponent is a 2, and this one, the highest exponent, would be a cube. So it could have a bunch of other numbers, but the highest exponent is 3. We don't usually memorize the quartic and the quintic. You can just say it's a 4th degree, 5th degree. Okay, a monomial is when you have one number or a product of numbers, so it could be 3, x, y, z. That would be a monomial. As soon as you add another term, add or subtract another term, it's a binomial because it has 1, 2 terms, and then you add a third term, it becomes a trinomial. If you add anything else, it is now a polynomial. So you're going to push pause here. Notice that you want to remember that the coefficient of a number that doesn't seem to have one is always 1. You're going to do these problems, and then we're going to discuss them. Okay, so if you look at this first one, putting it in standard form, we're going to move the 3x squared to the front. Make sure you put them in degree order. And the degree of this one is 2. The leading coefficient is 3. It has 3 terms, so it's a trinomial. This one, the leading coefficient is that. The degree is 1, and it's a monomial because it's one number. This one, we're going to move the 6x to the 8th to the front, and that makes the degree 8. The leading coefficient is 6, and it's a binomial because you have 2 terms. For the last one, we're going to put the f to the 4 up in front, followed by the f to the 2, then the f to the 1. The degree is only the highest, so it is 4, and the leading coefficient is 1, and it's a trinomial because it has 3 terms. Now we're going to talk about adding and subtracting polynomials. A lot of this seems like review, but it's applying itself to polynomials. So the set of polynomials is closed under addition and subtraction. That means the sum or difference of any 2 polynomials is also a polynomial. Now, if you're looking at something like this, that becomes 5x squared, but monomials are also polynomials. So you can see it is still a polynomial. Like terms are constants or terms with the same variable raised to the same power. So just as you perform operations on numbers, you can perform operations on polynomials. To add or subtract them, you're going to combine like terms. Okay, so when you're adding or subtracting, you need to look for those like terms. So I can see I have x to the 8th, so those will be like terms, and y to the 8th as well. Do not add the x's and y's, they are not like terms. So I have 2 x8s, and I have minus 1 x8, so I would have x to the 8th. Then I have 7 y to the 8th minus 1 y to the 8th would be plus 6 y to the 8th. Over here I can see that they both have the same exponents raised to the same power. So I'm going to add 9 plus 5 is 14 minus 13 equals 1 b cubed c squared. Polynomials can be added in vertical form. That means you line them up with the like exponents underneath each other and then just add the columns. In some instances, I like using this form, and in other instances, I like doing it horizontally, where in the book they show you to rearrange them like this, where you put all of them together. I just line them up and put my little symbols to show what my like terms are, and then I add the like terms. So the answer to this one, 5x squared plus 2x squared is 7x squared, 4x plus 5x is 9x, and 1 plus 2 is 3. So you can choose to do it this way. You can skip this step of grouping unless you find yourself dropping numbers and leaving things out. When you use the associative and commutative properties to rearrange the terms, the sign in front of each term must stay with that term. So we're going to distribute this, and we get that. This is a number. If I had to rearrange these, I would take the negative with that number. So the terms are negative 2x cubed, 3x, and negative 7. When you're looking at the terms, everything in between should be a plus. Okay, so if I was going to subtract this, I could, instead of doing this one horizontally, because you have to distribute first, what I would do is I would distribute, then I would put my like terms underneath the correct ones. So this would be negative 5m to the fourth. This is going to be positive 5m squared, because a negative times a negative, and then negative 8. Then I'm going to combine my terms. I get 7m to the fourth minus 5m to the fourth is 2m to the fourth. Negative 2 plus 5 is plus 3m squared, and don't forget your 8. There you go. Okay, so push pause again, complete these journal problems, and we can go over them at the end. Okay, here's the answers. If you got any of these wrong, we will go over them at the end. Okay, we're going to finish off with this example from the text. A penny is thrown straight down from a height of 200 feet. At the same time, a paintbrush is dropped from a height of 100 feet. The polynomials represent the height in feet of the objects after t seconds. So the first thing we're going to do is write a polynomial that represents the distance between the penny and the paintbrush after 10 seconds. So they want us to find the difference, and this is where you have to be careful, because when you subtract the whole term. Okay, the term represents one number, so you put it in parentheses, which means we distribute that negative, and we get positive 16t squared minus 100. Now we can combine our terms, so those are gone. We get negative 40t plus 100. Notice in the beginning we had a trinomial with a degree of 2, and now we have a binomial with a degree of 1. Okay, so let's interpret the coefficients of this polynomial that we've come up with. So the first part we're going to look at is the 100. And what the 100 tells us is that when t equals 0, the distance between the objects is 100 feet. You plug in 0 for t, and you're left with just the 100. We also know that this is the y-intercept. So if we were graphing these, it would start at the distance is 100. Okay? And that's at the beginning. So it's 100 feet here. Okay? As the value of t increases by 1, the value of negative 40t plus 100 decreases by 40. This is the slope of the equation. This means that the objects become 40 feet closer to each other after each second. So negative 40 represents the amount the distance between the objects changes each second. So if we were going to do 2 seconds, we would go negative 40 times 2 plus 100 would be negative 80 plus 100, and that would give us 20. So the distance is now 20 when we get down to that point. We don't usually draw a graph to show the difference. We would draw both graphs and see where they intersect. Okay, so that's the end of this PowerPoint. So if you didn't get the journal problems right, you can keep going. Otherwise, you're done. Okay, so we're going to do those journal problems now. Remember that your answers are in standard form, so pay attention to the degrees of each term. Okay, so the first one I noticed is a plus, so I can just combine my like terms. My highest degree is 1, so I'm just going to combine the negative 3a and the 7a, and I'm going to combine the negative 2 and the 5. And that is the answer. Okay. For the second one, I have to be careful because I have different degrees and they're not in standard form. So I'm going to look for the highest degree, which is 3. I'm going to add the 3t cubed plus negative 2t cubed, and I get 1t cubed. My next highest degree is squared, so I'm going to add t squared plus 2t squared, and I get 3t squared. Then I don't have any more variables in here, but I have one over here, so I'm going to add 7t. And don't forget your constant at the end. So that would be minus 3 at the end. Okay, for number 18, you need to distribute the negative. This is where vertical adding of the polynomials comes in handy, because you just distribute and then you add them below, and I get negative 12h minus 8. Okay, for this next one, you've got to be really careful. So the first thing I'm going to do is I'm going to distribute this, negative 5k cubed. I'm going to put it in standard form, plus 3k squared minus 7k. So now I've got this in order. I'm going to rewrite this one in standard form. So 6k cubed plus k squared. Notice that there's no k, or variable with an exponent of 1. So I'm going to leave a blank here. And then I'm going to put minus 4. Then I'm going to bring these up here that I already had. Negative 5k cubed plus 3k squared minus 7k, and there's no constant in that polynomial. So now I can combine. I get k cubed plus 4k squared minus 7k minus 4. And there's your answer. That's the end of this video.